A calorimeter is a device used to measure the heat transfer in a chemical reaction, and a really common reaction is the dissolving of a salt compound, like this pellet of NaOH, into water found in the calorimeter. So this reaction is actually highly exothermic. So that means heat is going to be released from the pellet and go into the water. So let's make a note that this is an exothermic reaction. Now notice there's a thermometer in my calorimeter that actually measures the temperature, not the heat, but I can convert it into heat using this formula, Q of surrounding equals mc delta T. So I'm also going to need to know the specific heat capacity in mass to get the heat transfer into the water. Now for the exothermic reaction, this is going to be positive because the water or surrounding is getting warmer, right? That's absorbing all the heat coming from the NaOH. Now in calorimetry, we're going to convert this into enthalpy or delta H of reaction using the formula Q of reaction divided by moles, in this case of the sodium hydroxide. Q of reaction is opposite of Q surrounding, so this will be negative, which means mathematically the enthalpy of reaction will be negative for an exothermic reaction. So exothermic reactions will have negative enthalpies, positive heats of surrounding, because heat is moving from the system into the surroundings. And if you want to see a more complicated example with a calculation, please let me know, and thank you for tuning in.